Zhongzheng, and today I'll be discussing the work of Holloway, Butler, and Marriott on the use of 3D printed mapping in orientation and mobility training. This work focuses on enhancing education and support for blind and low vision individuals. And onto today's roadmap here, I'll first briefly provide an overview of what this paper did, and then I'll go ahead to the introduction and related work section of the paper, and then I'll be talking about the three phases taken by the research team. So they first gathered information they needed before the design, and then they went ahead to their design phase, and in the end they evaluated their own design. And eventually we'll talk about their conclusions. And moving on to the next slide, I want to talk about what O&M is. So it's called Orientation and Mobility Training, provided for blind and low vision people. And it is designed to equip them with the skills to navigate around the world and just to travel independently. And one essential skill in the O&M training is learning how to cross street intersections. And this is what this work focused on. And 3D printed mapping, what they are, they're basically 3D printed models combined into creating a map. And this third dimension introduced by this technology usually just makes the map more engaging. So the research team identified three main questions. So they first try to identify the most important requirements for tactile materials, and then they try to see whether there's a need for additional O&M tools. And finally, they sort of summarized some design characteristics of successful 3D models. Onto their methodology. So the researchers had three main phases, like I talked about. So they first gathered information they needed, and they went ahead to this iterative co-design phase. And after that, they did some evaluation. And the contribution of this work is mainly empirical evidence. In the end, they provided some design guidelines for future 3D printed maps. And then they also published their design to online platforms, which are available for downloads. And then in the next three slides, I'll be talking about related work mentioned by the authors in this section. So onto the first slide here, we'll be looking at tactile maps and 3D printing. So the current field of tactile maps has been focusing on one feature, which is wayfinding. However, with the current available physical maps, we still lack fundamental details for understanding individual street crossings. And with the help of 3D printing, we can deliver better conveyance of information as well as better short-term recall. And then for 3D printed street crossings specifically, the authors mentioned available options on the market like Tactile Town, CookKit, and CityBox, as well as Lego. However, they also emphasized how whether these 3D models actually offer advantages over other tools. And then I want to talk about the approach taken by the researchers. So the approach taken by the researchers is what's called a participatory design. And this approach tries to engage multiple stakeholders from the entire process. And with this approach, we increase the likelihood of getting more practical and user-friendly solutions. It also is beneficial for future adoption and maintenance. So onto the first phase taken by the researchers. They first gathered information they needed before they went ahead to design. They try to see what's missing, what's needed, and what can they actually do to improve 3D maps. And they had this brainstorming and interview session with some O&M professionals and a blind adult, and then eventually they received feedbacks from the community. And After the interviews, the researchers used thematic analysis and concluded some results. So let's first take a look at several quotes. So the first quotes actually just highlight there's a need for tactile maps, specifically for people like refugees or children. And the second and the third quote kind of talk about the same thing, how the current available options on the market are too childish and just not technical enough. So they concluded these desired features and for what a well-designed 3D map should be. First is typical intersections we see in our day-to-day lives. We need to have T-intersections for intersections, and we also want these intersections to be customizable. And in addition to that, we need essential features like traffic islands, zebra crossings, or even pedestrians that would just make the 3D model closer to real-world scenarios. And like I mentioned, the research team took on this iterative and co-design process. So they worked alongside with O&M practitioners and blind adults. And then they sort of just received continuous feedbacks from them, and which they later added to improve their design. So in the next 3 slides, we'll be looking at the 3 designs came up by the research team. First design is a street layout puzzle pieces. And this design is created for to address typical intersection layouts like we talked about. So it has straight roads, T-intersections, and roundabouts. However, as we can see here, like there's still some features lacking, like pedestrians or even cars. So they came up with their second design, which is compatible with even just a random toy car. And they also made their second design more customizable. However, this second design, the research team realized when you put every piece together, it can take a lot of space. And how do you solve that? We can decrease the size of each piece, which led us to a third design come up by the research team, which is a 1 to 128 scale street corners. And as you can see in the photo here, it is more portable and compact. Now it's also customizable, and we're seeing more features like pedestrians or even a motorcycle. This final design is also available on Thingiverse if you guys are interested. And after the design process, the research team went ahead to this evaluation phase of their own design. And to do that, they also worked with O&M professionals and blind individuals, and they conducted survey and interviews. So from the survey result here, we can see the research team used this evaluation metrics called system usability scale. It basically studies how user-friendly and how usable a product can be. And as you can see from the figure here on the right, 3D printed models designed by the research team has a higher SUS score. And in their evaluation phase, they also summarized 13 requirements for creating good tactile street crossing materials. And those 13 key requirements can be further categorized into these 4 categories. They are support teaching required concepts, enable preferred teaching methods, ensuring accessibility, and addressing practicalities. They also summarized some advantages of 3D printed models as a production technology. So 3D printed models are durable and lightweight. They have good appearance in professional scope. They encourage play-based learning, and they're affordable and customizable. And besides summarizing the benefits for 3D printing as a technology, the research team also filtered some characteristics for successful 3D models. They generally have appropriate size, they're stable, they tend to have minimal details, and they're customizable. And onto the last two slides, I want to talk about my personal thought of the research. And I think, first of all, I think this research is a very well-structured research. Specifically, when we're taking human-computer interaction class, this is just extremely suitable. So if you remember the three phases taken by the research team, you will realize how they started from asking the question. They try to identify the problems by working with O&M professionals and blind individuals, and then they went ahead to this iterative design process while including the same people who are stakeholders. And then they evaluated their own design, which is a lot like what we have been doing in this semester. We learned various methodologies in how to identify the needs from our customers. And here I just want to highlight this multi-stakeholder approach taken by the research team and why is it good for accessibility settings. So in traditional approaches, we often see this low transferability. Something that worked in the lab room setting didn't work in a real life. And this multi-stakeholder is a good solution to that. By involving all stakeholders in this comprehensive process, you get diverse and unique perspectives. And it also allows for this continuous feedback. If you remember from this paper, the research team worked with O&M professionals and blind individuals along their three phases. They kept receiving feedbacks and suggestions from these highly related people. And on to the next slide, I want to talk about some limitations and suggestions from me. So first of all, the the design came up by the research team. It lacks some guide or just instructions. So I think in the future they can keep collaborating with the same people to provide some further lesson plans or printing instructions. And also, as you may know, there's regional differences across street intersections in different areas. So I think the research team can keep working with the O&M professionals to address this regional difference. And also in the design, the 3D models are still rather simple. So I hope the researchers can come up with more complicated design in the future. And the last limitation here is since the researchers are working with blind or low vision people, there's still huge difference in terms of tactile ability across the individual. Some people lost their sights early on, some people lost their sights more later on in their life, and their ability in perceiving tactile patterns or objects can be very different. So I think the research team can include a more diverse participant group in the future to address that problem. Thank you.